Greetings, the Astro 30 here yet again, and welcome back to the Amplifier channel. No, welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Thanks. Today I'm going to be looking at an old circuit published in December 1972 of Electronics Today International magazine, which is actually for a 100 watt guitar amplifier. There is, in a subsequent issue, the preamplifier for it, which is a little mixer. But we're going to look at the heart of it, which is this power amplifier circuit here. Now, reading the circuit description, he's called the output stage topology quasi-complementary, which it is not. It is basically a emitter-follower, or complementary emitter-follower output stage. Don't know where he got quasi-complementary from. Maybe it meant something different back in 1972, but I doubt it, considering quasi-complementary has been used since, well, before the 60s. So the actual circuit is pretty conventional. There's not really much to talk about. The VAS is down here. We've got a constant current source up here for the VAS, a VBE multiplier or bias spreader here, and a differential long tail pair input stage. Over here we've got this Xeno diode together with this 1K5, etc. coming off of the supply here. That's a constant current source for the input stage, and apparently around about 10 mA is flowing through the input stage all the time. Now, I'm not sure what the purpose of D1 down here is in the collector of the first transistor of the long tail pair, which drives the VAS. It may be being used for the forward voltage drop, 0.6 of a volt there, in an attempt to keep the DC offset of the input stage low. I don't know. Obviously, current's only going to flow in one direction because of that diode. But the input impedance here is rather interesting because we've got a 3.9K resistor going to ground, and that gives us approximately an input impedance of 3.9K. So it's a fairly low impedance input. The other issue is it's using old style transistors, the TT-800 and TT-801, which are little can style signal transistors that you can't get anymore. So when I actually breadboard this up, I'll be using BC546 and BC556 respectively for all the signal transistors. The two drivers over here are BD139 and 140 respectively. And the output devices are 2N3055 and MJ2955. Again, I'll be using different transistors here, more modern transistors. And then we've got 0.25 ohm degeneration resistors here, which is an odd value. I've actually got some 0.27, so I might actually change it to 0.27. They've also denoted these as 2 watt devices. They really should be 5 watt devices at the end of the day. Negative feedback is taken off of R9 here, which is a 4.7K with its gain set resistor of 220 ohm. Now that gives us a gain of roughly 22, which is fine. And I'll probably change the value of this potentiometer, which is the bias set pot, to 500 ohm, because back in the 70s 470 may have been a common value of potentiometer. Nowadays, over 50 years later, it's not a standard value. We've got a bit of DC decoupling on the negative rail here between the output stage and the input stage circuitry here with this resistor and capacitor respectively. And nastily, they've got a 3 amp fuse in the output path to the speaker. So that's going to be deleted, and it really should have series fuses on the supply rails or at the power supply, wherever you want to put them. So the actual project number of this is ETI-413. So this is the ETI-413 power amplifier. So what I want to do is I want to build this up on breadboard and test how well this works. I also want to know what its DC offset is, and if the bias adjusts, and does it pass a signal from its input to its output. So what I'm going to do is I'm going to build up just this front end section to the drivers and without the output stage connected, because these two drivers are referenced to the output bus by these two 47 ohm resistors. So these two drivers will work as an output stage, delivering very little current, and these resistors may get a little bit hot if you try to overdrive it. But unloaded, it's good enough to see if we're getting a signal from the input to the output point. So I'll spend the next hour or so building this up. Okay, so about an hour or so later, I've got the circuit breadboarded out, and I've already pre-tested it before turning the camera on. Initially the circuit does work, however the bias is not adjustable. I don't know why, maybe the value of the pot's too low, especially for the voltage I'm running at. I've got the supplies limited to about 100 mA, so if I now turn the output on, we can see that the base quiescent current, even with the potentiometer for the bias set to minimum, is 35 mA. I'm measuring the output with a multimeter, and it's currently about 12 millivolts of DC offset, which is it's acceptable. The other issue I've found is these drivers start to get considerably warm, but they're not actually connected to an output stage, and this bass transistor is getting kind of red hot. Well, not red hot, but it's very hot to the touch, so it may have to be changed. But what I want to know more than anything else is, does it actually pass the signal? Well, that would be a yes, and it's relatively clean, and it's not even showing any signs of ringing or oscillation, even without a Zobel network installed, which there should really be one, but there isn't. So I guess the next issue I want to tackle is the bias. So I'm going to fiddle around off camera with different pots and stuff until I can get an adjustable bias. I think the value of this pot needs to be more around about probably 2K, maybe 1K. I'll fiddle around with it off camera and see if I can get that bias to adjust. Alright, I've got a 1K variable resistor installed in place of the 500 ohm. Circuit is turned on, so if I vary the potentiometer, we can see that the current does go up, but it maxes out at about 40 mA. So I'm going to leave it around about the 30 mA mark. I think it's just because the voltage supply is a little too low. Now DC offset is only about 9 millivolt now, but that's okay. So what I want to do is I want to turn that off, because I haven't actually got the output stage connected, which is probably why the bias is not really adjustable. So I might back that back off to 0 ohms. I'll configure the output stage now and connect it up to some suitable output transistors with generation resistors, and try again. Output stage is connected and it is actually turned on. And I did find that I was right. If I adjust the bias pot now, I can actually get a lot higher than 40 mA of current in the output stage. See, we're up to about 66 mA, which is fine. I might go back to the 500 ohm because that's what the circuit called for, but what's concerning me is that VAS transistor is quite hot. The drivers are getting warm, but so they may require heat sinking, I'm not sure. But yeah, I'm going to have to monitor this. This VAS, yeah, when it's not really doing anything, shouldn't be getting that hot. So I'll reconnect my oscilloscope to the output point. Should really disconnect it first before doing this, but that's fine. And there, and I'll wind up the oscillator. Oh, there we go. So yeah, it is amplifying a signal with the output stage connected. So yeah, it's just the VAS transistor is a little bit concerning. But then again, I don't know what the original transistor that was there in the first place was actually rated at as per current. It could be because the constant current source is just pumping a little bit too much current in through the VAS circuitry there. Than is actually needed, is what I'm trying to say. As for the constant current source transistor, there's a bit of heat in that as well. Quite a fair bit of heat. The VBE multiplier is nice and cold. VAS is still getting hot. And the long tail pair Yeah, it's hard to tell, my finger's hot, but there is a bit of warmth there. Output stage is not doing anything, so okay. What I'm going to do is I'm going to leave this run for a few minutes on its own, come back and check the constant current source transistor and the VAS transistor and the drivers and see if they've heated up any further. I don't think they will, but that is fairly hot to the touch. And that's probably about half the, about the same. Alright, let me let that run for a few minutes and I'll come back. So it's been sitting about 5 minutes. DC offset hasn't changed, it's still around 10 millivolts, it's still outputting a signal. And, well, honestly, if anything, this constant current source transistor is hotter than the VAS. But it hasn't really changed in temperature that much. And the drivers are warm, they're not overly hot. So what I'm going to do is I'm going to go back to the 500 ohm trim pot, see if the bias adjusts nicely, because this is supposed to be biased around 80 MA apparently, which seems a little bit on the high side. Probably 50 MA would be about right and better. And once I've done that, I'll load the amplifier into an 8 ohm load and see if it performs okay and what power it's producing. I've got the amplifier's output loaded now, and no, the 500 ohm pot still does not work correctly in the circuit, so it doesn't actually adjust the bias at all. Maybe because the voltage is low, it should be plus minus 35 volts or close to, but I'm going to leave it at 1K for now. It seems to be functioning okay. So I'll ramp up the oscillator. Bang! No, it's not serious. There's clipping, back it off. About 16.9 volt RMS, so near about 38 watts RMS, something like that. 35 watts. Okay, now I guess I'll load it into 4 ohms now and do the test again. As I don't want anything bad or disastrous to happen, I'll turn the load off first before doing this. Or the supplies off before doing it, I should say. Move over to 4 ohm position. Alright, turn it back on. Nothing unusual happened, great. So let's ramp the oscillator up. Well, I'm going into current limit somewhere. So I'm going to change the current to about 1.6 amps. Try that again. Yeah, that's about right, okay. So I'm going to say 13 volt RMS thereabouts. About 42 watts. So yeah, it's a little bit higher than the 8 ohm load, so that's fine. Excellent. So it is actually working as it should. That is quite hot. This really needs to be, that's not too bad. This really needs to be changed to something else like a BD-139 or something. The drivers seem fine. So, okay, I'm going to mess around with this circuit off camera later, but for completeness of this video, I guess I will pump it into a speaker with an audio signal and just hear how it sounds. Speaker is connected, but it's not turned on yet, so I'm going to turn that on, and I haven't connected the other end of the speaker yet. Just want to hear if there's any unusual noises. Not really. So I'll connect the speaker. I can't actually hear anything, which is odd to say the least. Alright, let's see if we've got an audio signal coming out. I've got the computer connected to the input. Yeah, it is outputting. Just don't seem to have much gain. That's why. like the input shorted against the the ground. Okay, well, sounds alright, but yeah, this VAS transistor and its associated constant current source needs to change to a beefier transistor. So BD140 for the constant current source and BD139 for the VAS. So I'd have to play with this off camera and just to make those modifications and see if it works okay. And what am I going to do with this? No idea. But what's next? Well, I may route a PCB for it. May. I don't know. But yeah, I'm concerned about the VAS and the constant current source, as I said. So they really do need to change. Other than that, the circuit does operate. Produces, I think it was 35 watt into 8 ohm at plus minus 30 volts. And just over 40 watts into 4 ohms at plus minus 30 volts. So yeah, that's good enough. And I'll just leave this video here, and well, if you enjoyed it, that's great. I enjoyed putting it together and testing it, and If you've got any thoughts, leave them below in the comments. I'm the Astro 30, and if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya, thanks for watching, have a great day.